You know, every single second of every day, there's a silent, microscopic war being waged right inside of you. It's this high-stakes battle between foreign invaders and your body's own elite defense force. So today, we're going to pull back the curtain on this fight and introduce you to the two main players, antigens and antibodies. Let's just dive right in and see how your body defends itself.
I mean, think about it. The sheer number of potential threats is just overwhelming. You got bacteria, viruses, toxins, they are all trying to get in. So how on earth does your body manage to win this constant, relentless battle for survival? Well, the answer lies in a system of just incredible precision and power.
To really understand this battle, we first need to meet the combatants. On one side, we have the intruders. We call them antigens. And on the other side, we have our protectors, the antibodies.
Okay, first up is the antigen. This is the bad guy. An antigen is basically any substance your body doesn't recognize that makes your immune system sound the alarm. It could be part of a virus, a little piece of a bacterium, or even just pollen. Essentially, it's the molecular face of the enemy. And to fight that enemy, your body produces a hero, the antibody. These are these incredible Y-shaped proteins that are manufactured by your B cells. Now, they aren't just generic soldiers, they are custom-designed weapons, each one created with one single mission: find and neutralize one specific type of antigen. And you know, this is the whole idea behind vaccines, right? To introduce a harmless piece of an antigen so your body can go ahead and pre-build a custom army of antibodies, all ready for the real thing.
And here you can see the secret to their success. You see those tips on the Y of the antibody? Those are the antigen binding sites, and they are shaped to fit their target antigen perfectly, just like a key sliding into a lock. It's this perfect match that makes sure the right defender always finds the right intruder.
So this perfect match is the secret to our immune system's success. It is all about precision targeting, which brings us to our next point.
And that brings us to this really crucial concept called specificity. This basically means that an antibody that's designed to fight, say, the flu virus won't even notice a common cold virus floating by. Each antibody is a highly trained specialist, programmed to recognize and bind only one specific target. And this prevents total chaos and ensures a really focused, effective attack.
So, how strong is this bond? Well, we actually measure it in two different ways. First, there's affinity. That's the strength of a single connection. Think of it like a firm handshake between one arm of the antibody and the antigen. But then you have avidity, and that's the overall strength of all the connections combined. It's the difference between one handshake and a whole team locking arms together.
And this visual really drives the point home. On the right, that's affinity, a single point of contact. But look to the left, that's avidity. You've got multiple antibodies just ganging up on the same intruder. This creates a bond that's exponentially stronger and almost impossible to break. It's this kind of teamwork that gives our immune system its incredible holding power.
Okay, so we've met the intruder and the defender, and we know they bind with this incredible strength and specificity. Now let's watch how the actual battle unfolds, because it happens in three pretty distinct stages.
Act 1 is the primary stage. This is the initial, silent lock-and-key connection. It's all happening at a molecular level, so it's completely invisible to us. Act 2 is the secondary stage, and this is where things get interesting. As more and more antibodies bind, they start clumping the antigens together, creating a visible reaction. And finally, Act 3, the third stage. This is the endgame, the complete destruction or neutralization of the invader.
Now, the outcome of this three-act drama can be incredibly beneficial. I mean, it can literally save your life. But this powerful system can also have a dark side, and it can cause some unintended harm.
So the crucial point here is that these antigen-antibody reactions are a total double-edged sword. When they work correctly, they are the absolute foundation of our immune defense. But when they misfire or overreact, they can lead to things like allergies or even autoimmune diseases, where the body actually starts attacking itself.
Let's start with the good news. Remember that secondary stage we mentioned? Well, agglutination is a perfect example of that. As you can see with these blood cells, antibodies act like molecular handcuffs, just clumping all the invaders together. This creates a big, obvious target for other immune cells to come in and clean up. It's a super efficient way to round up all the bad guys.
Another brilliant strategy is something called precipitation. This happens when the antigen is soluble, meaning it's dissolved in your body fluids. Now, for this to work, you need the perfect ratio of antibodies to antigens, what this graph calls the equivalence zone. In that sweet spot, they bind together and form a solid, insoluble complex that literally just falls out a solution, making it simple for your body to filter it out and destroy it.
Okay,
This next one is seriously cool. It's called antibody-dependent cell-mediated cytotoxicity, or ADCC. Yeah, I know, it's a mouthful, but the idea is actually pretty simple. The antibody doesn't kill the target itself. Instead, it acts like a beacon, tagging a bad cell, like a tumor cell. This tag calls in the special forces, in this case, a natural killer cell. The NK cell locks on and delivers the fatal blow. It's like a precision-guided missile at the cellular level.
But what happens when this powerful system makes a mistake? When it identifies something totally harmless, like pollen, as a major threat? Well, that's when you get allergies. And sometimes, in the most tragic cases of mistaken identity, the system loses its ability to tell self from non-self. And this is when you get autoimmune diseases, where these powerful weapons are turned against your own healthy tissues.
So it really leaves us with this profound question. Our immune system is a masterpiece of biological engineering, our ultimate defender in a constant, invisible war. But its greatest strength, its incredible power and specificity, is also its greatest vulnerability. It just reminds us of the delicate balance required to protect us, where the line between defender and destroyer is finer than we might think.